Okay, we're going to go through the first few problems from the homework. And these are really very similar to what we've been doing with the roller coaster lab and the skate park simulation that we did in class. So we've got a roller coaster here. We're going to assume this is an isolated system. So we're going to be analyzing like the coaster, car, and the earth as our isolated system. We're given the mass of the coaster, and we assume it starts from this point, okay, up here, and it starts at rest, okay. So we're going to try and figure out gravitational potential energy, kinetic energy, and total mechanical energy at these 4 points. So we've got our initial point, we've got 2 other heights, and we've got a final point, and we're going to assume our coaster starts here from rest, it travels downwards, and eventually it's traveling along the ground here at no height. Okay. So, I'm going to reference back and forth between these papers, but that way you can see everything written down. So at point A, I'm at rest there. So that means that my kinetic energy is 0 because I'm not moving. That means all of my energy at that point, so that's at this point here, point A, is gravitational potential, or UG. And I can calculate that by mass times G times H. My mass is 40 kilograms. G is still 9.8. And my height at this top point is 10 meters. So I multiply that all out. I get 3,920 joules. Remember, joules is our unit for energy. I know my total bucket of mechanical energy here is equal to my potential plus my kinetic. And this is the number that's conserved. So this should be the same total at any point, whatever combination of these we're looking at. Okay, we're going to get the same number here. So in the case of my point A, okay, if I've got 3,920 joules of gravitational potential and I have 0 of kinetic, that tells me my total mechanical energy is 3,920 joules. So that's going to be the same number. I get this number for point A. It's going to be the same number for for point B. I'm saying number C here. For point B, for point C, and point D. All of these, I can go ahead and fill in this total mechanical energy value because it's constant and it's conserved. It's not going to change. I'm just going to see my energy within that bucket change as I go through the points of the roller coaster. So points B and C, I can see that I've still got some height. I'm also going to have some kinetic energy at those points because I'm moving. So I can get those energies by figuring out my gravitational potential because I've got the information I need to do that. I've got height. My mass is still 40 kilograms. I know what G is. I don't know velocity, so I'm going to solve for potential energy at point B. I'll call that UGB. It's going to be my 40 kilogram mass times my 9.8 times my 5 meter height here. This one's a 5 meter height. When I multiply those, I got 1,960 joules. Okay. Again, I already know my total mechanical energy is 3,920. And I know that total ME equals UG plus KE. I know what UG is here. And I know what my total mechanical is because it's the same at all the points. So I can solve here for kinetic energy. And I'm just going to subtract this 1,960 from both sides. I end up getting also 1,960 here. So my energy is half potential, half kinetic at this point. I'm half the height I was at my initial point. So that hopefully make sense in terms of the, the way the problem is working. I've got half my energy converted now into kinetic. When I look at point C, okay, again, I don't have any information on velocity, so I'm just going to do mass times G times H. H here is 7.5 meters. And get a value for that. That's going to give me, let's see, I got 2,940, and that's just multiplying those all together. Again here, total mechanical equals 3920 joules, and that equals my potential at this point, 2940, plus my kinetic. I can do the same thing here. I can subtract 2940 from both sides, and I end up with kinetic energy equals 980 joules. So I've lost back some of my kinetic energy to potential when I go back up. Okay, so I come down this hill, I'm about half and half right here. And then as I go back up the hill, I'm still moving, so I still got kinetic, but I've increased my height, so some of my energy is converted back into potential. And you can have that in the system depending on how it works. You can have energy that transfers back and forth between both of them. Okay. Now my final point, point D, I have no height here. Okay, so I should be able to already guess that my UG at this point is 0 because my height is 0. That means that all of my energy equals my total mechanical, and it equals all my energy is kinetic, and that equals total mechanical, and that's 3,920 joules. And if I wanted to get velocities anywhere, I could do that now that I've got this kinetic energy value. I didn't ask y'all for that, but I could use kinetic energy equals 1/2 times m times v squared. And you did this in your lab, okay? So, but you're just solving this equation for velocity. Okay, so that is the first few problems on the homework. That's the ones that I said you should look at for the formative tomorrow, these 4. And I'll go through more problems in the next video.